This is the Edexcel Foundation tier, paper 2 calculator paper from November 2019. Question 1 says write these numbers in order of size. Start with the smallest number. So the smallest number is the biggest negative number. So that's -7. Then we've got -4. Then -2. And then into the positive numbers, 1 and 8. Question 2. Write the number 8,375 correct to the nearest thousand. So we've got the thousands column here. So we're going to look at the next number down, which is a 3. If it's 5 or above, we round up. If it's below 5, we leave it as it is. So we're going to leave it as it is, and it's going to stay as an 8. So it's closer to 8,000 than it is to 9,000. The nearest thousand is 8,000. Question 3, write 0.23 as a percentage. To change a decimal to a percentage, we times by 100. So 0.23 times 100. And if we want to use the calculator, we can. 0.23 times 100 is 23. So that's 23%. Question 4. Find the value of square root 17.64. Again, we're going to use the calculator. So square root 17.64 is, I've got 21 over 5, or 4.2. Question 5. Find the value of 6 to the power of 5. So again, let's pick up the calculator. 6 to the power of 5 is 7,776. Question 6. There are 14 rows of seats in a cinema. There are 15 seats in each row. So we're going to need to know how many seats. So 14 rows, each with 15 seats on them. 14 times 15 is 210. So 210 seats. A film was shown in the cinema on Saturday. Each ticket for the film cost £6.50. The tickets that were sold cost a total of £12,074. How many tickets were not sold? So £6.50 each, and the total was £1,274. So £6.50 times the number of tickets sold must be equal to 1,274. So if we want to find the number of tickets sold, we can divide. We can do 1,274 divided by £6.50. And that's 196. So 196 tickets were sold. 196 £6.50s make 1,274. The question says how many tickets were not sold. So there are 210 seats, 196 tickets are sold. So take away 210, take away our last answer, which was 196, is 14. So 14 tickets were not sold. Question 7. Harry has 20 sweets. He gives 7 of the sweets to Nadia. What fraction of the 20 sweets does Harry now have? So he had 20. He gave 7 away, so he has 13 sweets now. What's that as a fraction of 20? What's that out of 20? So 13 20ths. He has 13 sweets out of 20 sweets in total. Question 8. Here is a number machine. Work out, so we're going to times by 8 and then take away 5. So you put a number in, times it by 8, take away 5, and then a number comes out the other side. We need to work out the output when the input is 6. So we're putting 6 into this number machine. So we're going to times it by 8. 6 times 8 is 48. And then we're going to take away 5. So 48 take away 5 is 43. Here is a different number machine. So we're putting a number in, we're adding 13, and then we're going to do something else to get the number out. So when we're putting 17 in, when the input is 17, the output is 10, complete the number machine. So 17 plus 13, 17 plus 13 is 30. So we've got 30 here. What have we got to do to get to 10? So we've got 2 options really. We can divide by 3, or we could have also taken away 20. Either one of those 2 answers would get us to 10. Question 9. Here is a list of numbers. Work out the median. So to work out the median, we're looking for the middle number, but first we need to put the numbers in order. So let's order these numbers. We go lowest to highest. So we've got 3, then we've got 2 4s, a 6, an 8, and a 9. So we've rewritten them in order. So where's the middle number? So if we cross off 2 from each side, we're left with 2 numbers in the middle. So when that happens, we go halfway between the 2 numbers that are left. So halfway between, or what's the middle of 4 and 6? The middle of 4 and 6 is 5. So the median is 5. Aisha picks at random one of the numbers. What is the probability she picks an odd number? So how many odd numbers are there? There is 9 and 3. So there are 2 odd numbers out of 6 numbers in total. So the probability is 2 out of 6. You could simplify that to 1/3, but you don't have to. So 2 out of 6 is a perfectly good answer. Clara has 5 cards. There is a number on each card. 2 of the numbers are hidden. The mode of the 5 numbers is 3. So the most common number is 3. So straight away we can say there must be another 3. The mean of the 5 numbers is 5. So the mean is where you add up all the numbers and divide by how many. And if the mean is 5 and there are 5 cards, the total they must all add up to is 5 times 5. So they must all add up to 25, because 25 divided by 5 is the mean. 25 divided by 5 is 5. So they must add up to 25. At the moment, we've got 3, 3, 8, and 5. So what does that add up to? So So we'll type it in the calculator and we get 19. So what's left? 25 take away 19, which is 6. So the other number must be a 6. So now we've got a mode of 3 and a mean of 5. So the missing numbers are 3 and 6. Question 10. Here is the charge at a car park in Spain. So it's 0.024 euros per minute. John parked his car in this car park. He drove into the car park at 10:45. When he drove out, he had to pay 8.48 euros 40 cents. So what time did he leave? So we can work out how many minutes he was there. 8 euros 40 is what he paid. So it's 0.024 times the number of minutes equals 8 euros 40. So we can find the number of minutes by dividing by 0.024. So this will tell us how many minutes he was in the car park. So we'll use the calculator. 8.4 divided by 0.024 is 350 minutes. So what time did he leave? So we need to add 350 minutes onto 10:45. So how many hours is that? If we press this button, it doesn't work. So divide by 60. So we get 5.83. So we press this button, 5 hours 50 minutes. So 5.83 hours or 5 hours 50 minutes. So 5 hours and 50 minutes. So now we need to add on to 10:45. So we could go 10:45 and add on 5 hours, which will go to 15:45. And then 15 minutes will take us to 1600. And then we've got 35 minutes left. For 16:35. So that's the time he left the car park. On the calculator, so we could do 10:45, 10 hours, 45 minutes, plus 5 hours, 50 minutes, and we get 16:35, which is the time he leaves the car park. Question 11. You can use this graph to change between stones and kilograms. So we've got a conversion graph. Change 3 stones into kilograms. So we're just going to find 3 stones on here, on the graph. So we'll go from 3, we'll go up to the line, then across. I think I've missed it slightly, but we should get 19. So we've got 19 kilograms. Change 80 kilograms into stones. So 80 isn't on our conversion graph. We can't do 80. The graph doesn't go up to 80, but we can do 40 and double it, or 20 and times it by 4, or 60 plus 20. Any method to get to 80 kilograms. So if we go to 40 kilograms, which comes out as, so it goes 6, 6.2, 6.4, 6.6, 6.87. So it's halfway between 6.2 and 6.4, which will be 6.3. So 40 kilograms is 6.3 stones. So if we double 40, we could double 6.3, which we can use the calculator for. 6.3 times 2 is 12.6. So we've got 12.6 stones. Question 12. Find the number that is exactly halfway between 1/10 and 3/5. To find the middle of two numbers, we can add them together and then half the answer. So if we had 4 and 6, to find the middle of them, we could do 4 plus 6, which is 10, and then half 10, which is 5. So to find the middle of two numbers, we can add them up and then half the answer. So let's add them together using the calculator. So 1/10 plus 3/5, which is 7/10, and then half the answer. So half of 7/10, so divided by 2, is 7/20. So exactly halfway between 1/10 and 3/5 is 7/20. If we didn't have a calculator, we would have had to make the denominators the same. So we could have said, I've got 1/10, and if I double the top and bottom for 3/5, I've got 6/10. Then we could have gone halfway between 1 and 6. So halfway between 1 and 6 is 3.5. So we could have said we've got 3.5 tenths. And if we double top and bottom, 7/20. But we did have a calculator, so we can use it. Question 13. On the grid, draw an enlargement of the shape with a scale factor 3. So we're drawing the shape 3 times bigger. We can draw it wherever we like, as long as we make it 3 times bigger. So the base was 2 to start with. So 2 times 3 is 6. So the base is now going to be 6. This side here was 2 tall again. So 2 times 3 is 6. So now that's 6 tall. To get from the bottom corner to the top corner, we went along 3, up 3 to start with. In the original shape, it was along 3, up 3. So we're going to times that by 3. 3 3s are 9. So now it's along 9, up 9. So along 3, 6, 9, and up 3, 6, 9. And then let's connect those points up. And there is our enlarged shape. So every length, if we measured it now, will be 3 times as big as the original shape. And you can check that with a ruler. You can check that this length is 3 times bigger than this length. Question 14. A shop sells compost in 20-litre bags and 40-litre bags. One day the shop had 2 special offers for the compost. So for the 20-litre bags, we're getting 2 bags for £3.50. And for the 40 litres, we're getting 3 bags for £9. Which offer is better value for money? So 2 bags of compost, 2 bags of 20 litres. So if I write 20 litres, 2 bags, 2 20s are 40 litres. So we're getting 40 litres for £3.50. For the 40-litre bags, we're getting 3 bags, which is 3 40s, which is 120. So 120 litres for £9. So which is better value for money? So we could, well, we've got to make them the same somehow. So we've got 40 litres and 120 litres. So if I do 40 times 3, if I multiply this one by 3, I'll make it 120 litres. So then they'll be the same and we can compare them. So if I buy this 3 times, we'll have 120 litres, because 40 times 3 is 120, and that will cost £3.50 times 3, which is £10.50. So which is better value for money? So we can get 120 litres for £10.50, or 120 litres for £9. So the 40-litre bags are better value for money. Question 15. The length of a plane is 19.2 meters. Lucas buys a scale model of the plane. The scale of the model is 1 to 24. Work out the length of the scale model of the plane. Give your answer in centimeters. So let's change it to centimeters first. So the length of the plane is 19.2 meters. To change meters into centimeters, we're going to times by 100. So 19.2 times 100 is 1,920. So that's the length of the plane in centimeters, and the scale of the model is 1 to 24. So if we divide by 24, we will find how big the scale model is. So divide by 24, and that's 80 centimeters. So we're saying 80 to 1,920 is the same as 1 to 24. So it's 80 centimeters. Maria invests £4,500 in a savings account for 3 years. The account pays simple interest at a rate of 1.8% per year. Work out the total amount of interest Maria gets by the end of the 3 years. So she's getting 1.8% each year. So we need to know what 1.8% of 4,500 is. So 1.8% times 4,500. Or if we write this as a decimal, to change a percentage to a decimal, you divide by 100. So that's 0.018. 0.018 times by 4,500. So wherever we're working out the percentage of 1.8% of 4,500, we're writing a times sign. So 1.8% times 4,500. So this calculation, so this number times 4,500, that's the interest each year. So £81 a year and it's 3 years, so we need to multiply by 3. 81 times 3 is 243. So £243. Question 17. ABC is a straight line. AB equals BC equals BD, and angle DAB is 64 degrees. All of that information we can see on the diagram. And the question says, work out the size of the angle marked X. Give a reason for each stage of your working. So all of these equal lines give us isosceles triangles. And the angles at the base of an isosceles triangle are equal. So for triangle ABD, the two angles at the base are the two angles underneath the equal lines. So this angle and this angle are equal. So angle ADB must be 64 degrees. And then at triangle BCD is also an isosceles triangle, and the two angles at the base are equal, and the base angles are the ones underneath these two equal lines. So angle X equals this angle up here. So we need to give reasons for each stage of our working. So let's start by saying that ADB is 64 degrees because angles at the base of an isosceles triangle are equal. Then for triangle ABD, we can say that angles in the triangle add up to 180 degrees. So ABD is going to be equal to 180, take away the 264 degrees. So we can work that out on the calculator. 180 take away 64, take away 64, and that's 52 degrees. So we've got a 52 degree angle here, and that's because angles in a triangle add up to 180 degrees. Then we can use angles on a straight line to find CBD. So CBD, angles on a straight line add up to 180 degrees again. So 180 take away 52 is 128 degrees. So we've got 128 degrees for CBD. And then we can use the angles at the base of an isosceles triangle are equal again. So the angles in this triangle have to add up to 180. So 180 take away 128 will give us what's left for the two green angles, and To find out what each one is worth, we can half it, because they must be equal. So again, angles at the base of an isosceles triangle are equal. So let's type it in the calculator. 180 take away 128 divided by 2 is 26 degrees. So x is 26 degrees. Question 18. Ben is n years old. Chloe is twice as old as Ben. So if Ben is n years old, 2 times that is 2n. So Chloe is 2n years old, and Dan is 5 years younger than Ben. So 5 less than n is n take away 5. The total of Ben's age, Chloe's age, and Dan's age is t years. Find a formula for t in terms of n. So t, the total of their ages, is equal to Ben's age plus Chloe's age plus Dan's age. So to simplify this, we collect like terms. We've got 1n plus 2n's plus another 1n. 1 plus 2 plus 1 is 4. So we've got 4n's take away 5. T is equal to 4n minus 5. Part B, in the table below, put a tick in the box next to the identity. So the side where, so an identity, the left-hand side is exactly the same as the right-hand side. So the first one's an equation. The second one we've got here, we've got no equal sign, it's an expression. The area equals pi r squared is the formula. 5m minus 3m is 2m. So the left side and the right side are exactly the same. The left side can be simplified to make the right side. So that's the identity. And the last one is an inequality. Question 19. Here are the ingredients needed to make 16 biscuits. So for 16 biscuits, we need 175 grams of butter, 75 grams of sugar, and 250 grams of flour. And then Anna has 500 grams of butter, 350 grams of sugar, and 625 grams of flour. We need to work out the greatest number of biscuits Anna can make. So we need to figure out how many biscuits she can make with the amount of butter she has, how many with the amount of sugar, and how many with the amount of flour she has, and then the lowest one of those will be our answer. So for butter, if we do 500 divided by 175, which will give us 20 over 7. So that's, she's got 2.8 times as much as this recipe. So she can make 2.8 times as many. So 16 times 20 over 7. So times it by 16 is, well, 45 biscuits. So she's got enough butter to make 45 biscuits. For sugar, so 300 over 75 which is 4, and then 4 times 16 is 64, so we've got enough sugar for 64 biscuits. And for flour, 625 over 250 is 2.5. So 2.5 times 16 is 40 biscuits. So we've got 40, 45, 45, 64 and 40. So how many biscuits can she make? Well, she's only got enough flour for 40 biscuits. So that's how many she can make with the ingredients that she has. Question 20. An estimate of the height, h meters, of a tall building can be found using the formula, where the building is F floors high. So h, the height of the building, is 4 times the number of floors plus 12. A tall building is 110 floors high. The real height of the building is 442 meters. Seb uses the formula, so this formula, to find an estimate for the height of the building. He then finds the difference between his estimate and the real height. So let's look at the estimate, and we need to show that there's less than 5% of difference. So the height, the estimate for the height, is 4 times the number of floors, which is 110, plus 12. So 4 times 110 plus 12 is 452. So the estimate is 452 meters. So then we're finding the difference between the estimate and the real height. So 452 take away 442 is 10 meters. So that's the difference. Show that this difference is less than 5% of the real height. So the difference is 10 meters. The real height is 442 meters. So 10 over 442 is a fraction. That's what fraction it is of the real height. And to make it a percentage, times by 100. So 10 over 442 times 100. And it's, well, I've got 2.26%. 2.26%. So it's less than 5% because it's 2.26%. Is less than 5%. We could have also worked out 5% of the real height. So 0.05 times 442, which is 22.1, and said 10 is less than 22.1. Question 21. The table shows some information about the weights of 50 potatoes. And we've got our frequency table here. And then we're told that we've got a frequency polygon and it's not correct, and we need to say what's wrong with the frequency polygon. So the first thing that's wrong, well, I should say before I say what's wrong, so for a frequency polygon, we should be plotting the midpoint against the frequency. The midpoint against the frequency for all of these points, and then join the points up with a ruler. We shouldn't be joining the first and last point together. So two things that are wrong. the first and last points should not be joined together. So this line here shouldn't be there. So what else is wrong? Let's have a look. So midpoint against frequency. Our first point should be 15.6, which is here. So the first point is not plotted correctly. It should be at 15.6. So the first point should be at 15.6. And we don't need anything else. We could also say there's no label on this axis for frequency. So there's no label on this axis. And I'm assuming the rest of the points are correct. So 25, 21, 35, 13, 45, 7, and 55, 3. They look right. So they are all the possible reasons. Question 22. The length of a pencil is 128 millimeters, correct to the nearest millimeter. Complete the error interval for the length of the pencil. So it's 128 millimeters. The one above would be 129, and the one below would be 127. To be rounded to 128 millimeters, it must be in between these two midpoints. So halfway between 127 and 128 is 127.5, and halfway between 128 and 129 is 128.5. So to be rounded to 128 millimeters, it must be in between 127.5 millimeters and 128.5 millimeters. And you'll see that the inequality signs show that it can equal 127.5, but it can be anything up to but not including 128.5. Question 23. Tom and Adam have a total of 240 stamps. The ratio of the number of Tom's stamps to the number of Adam's stamps is 3:7. Tom buys some stamps from Adam. The ratio of Tom's stamps to Adam's stamps is now 3:5. How many stamps did Tom buy from Adam? So we're going to share 240 in the ratio 3:7. And then we're going to also share 240 in the ratio 3:5 and see how many stamps that they've changed. So 3:7 for the first one. That's 3 parts to 7 parts. So we've got 3 parts for Tom and 7 parts for Adam. So 3:7. In total, there are 10 parts. So there are 10 in total. So if we do 240 divided by 10, we'll get 24. So each part, each box here, is 24 stamps. So 24 in each of these boxes. And so Tom has 3 lots of 24, 3 times 24, and Adam has 7 lots of 24. And we can work out how many that is on a calculator. So 3 24s are 72. 7 24s are 168. So that's how many stamps they start with. And then after Tom buys some stamps, the ratio changes to 3 to 5. So 3 parts and 5 parts. So now there are 8 parts in total. There are still 240 stamps. So 240 divided by 8, which is 30. So now each of these boxes is worth 30. So Tom is going to have 3 lots of 30, and Adam will have 5 lots of 30. So 3 times 30 and 5 times 30. 3 30s will be 90. 5 30s 150. So now we can look at how many stamps that they've switched. So initially, Tom had 72 and Adam had 168. And after Tom bought some, Tom has got 90 and Adam has got 150. So how many has Tom bought? So 90 take away 72 is 18. So Tom has bought 18 stamps. Tom's stamps have gone from 72 to 90, which means they've gone up by 18. Question 24. Each person in a fitness club is going to get a free gift. Stan is going to order the gifts. Stan takes a sample of 50 people in the fitness club. He asks each person to tell him the gift they would like, and with a table gives information about his results. So in total there are 700 people in the fitness club. How many sports bags? So sports bags should Stan order. So in the sample, 17 people out of 50 wanted a sports bag. So if we assume that the same proportion of people will want a sports bag in total, so this fraction of, and for of, I'm writing it times 700. So 17 over 50 times 700 is 238. So we're going to assume he should order 238 sports bags. Write down any assumption you made and explain how this could affect your answer. So we've assumed that the sample, so we assumed the sample is representative of all of the members, all of the people in the club. So if he had only asked men what they liked, he'd only asked 50 men, it might not be representative of all the people because the women might want something different. Or if it only asked older people what they want, younger people might want something different. So we're assuming that this sample he's taken is representative of all 700 people. And explain how this could affect your answer. Well, if it is not, the answer, well, it could be higher or lower, would be inaccurate. The answer would not be accurate. Question 25. Here are 6 graphs. So we've got a what looks like an x squared graph, y equals x squared. We've got a cubic graph. We've got a reciprocal, a negative reciprocal graph, so a negative reciprocal. We've got an x squared. We've got a negative reciprocal. We've got some kind of cubic graph. So, well, actually, f, it looks like y equals x cubed. B is something like some other cubic, so a more complicated cubic. D is a positive reciprocal. And E is a straight line graph, y equals mx plus c. So write down the letter that could have each of these equations. So y equals x cubed, that's our graph f. And the 1 over x, that's the positive, so starts in bottom left, goes to top right, the positive reciprocal, that's D. Question 26. The nth term of a sequence is 2n squared minus 1. The nth term of a different sequence is 40 minus n squared. Show that there is only one number that is in both of these sequences. So let's just list the ones in each sequence. So this sequence is going to be going up, going to be getting bigger each term. This sequence is going to be going down. So let's just list the terms in them, and we should find one term that's the same in both. So to find the first term, we substitute in 1. So 2 times 1 squared, take away 1. So 2 times 1 squared minus 1, and that's 1. So the first term is 1. For the second term, I'm going to substitute in 2. And that gives me 7. For the third term, I'm substituting in 3, which is 17. For the fourth term, substitute in 4. That's 31. And we'll do another one. The fifth term is 49. So 2 times 5 squared, take away 1, is 49. Now that's over 40, so I know that's going to be high enough. So for my second sequence, it's 40 take away 1 squared, which is 40 take away 1, which will be 39. 40 take away 2 squared. 40 take away 4 is 36. 40 take away 3 squared. 40 take away 9, 31. We've got 40 take away 4 squared. 40 take away 16 is 24. 40 take away 5 squared. 40 take away 25, which is 15. And then 40 take away 6 squared. 40 take away 36 is 4. And then just to show we've gone past 1, we'll do 40 take away 7 squared, which will be 40 take away 49, which will be negative 9. So we should be able to see there's only one number in both of these sequences, and that's 31. So only 31 is in both. Question 27. Work out 3.42 times 10 to the power of negative 7 divided by 7.5 times 10 to the power of negative 6. So I'm just going to type this in the calculator and see what I get out. So I've got 3.42 times 10 to the power of negative 7 over 7.5 times 10 to the power of negative 6. So what am I getting out? So I've got a decimal, 0.0 456. So I've got 0.0456. That's a decimal. It's not in standard form. So I need to write it in standard form. So that will be a number between 1 and 10. So 4.56. Then times 10 to a power. And to get from 4.56 to 0.0456, I need to go back to divide by 10 twice. So it's times 10 to the power of negative 2. And I can check my answer by typing this in the calculator. So 4.56 times 10 to the power of negative 2, press equals, and that takes me back to 0.0456. So I know I have the correct answer. Question 28. The number of days, D, that it will take to build a house is given by D equals 720 over N, where N is the number of workers used each day. Ali's company will take 40 days to build the house. Haley's company will take 30 days. Haley's company will have to use more workers. How many more? So the number of days is 720 divided by the number of workers. So for Ali, it takes 40 days. So 40 is 720 divided by the number of workers. So what is N? To solve this equation, we can times both sides by N. So we'll have 40N equals 720. I then divide both sides by 40. So 720 over 40 is 18. So 18 workers for Ali's company, and for Haley 30 days. So 30 is 720 over N, times both sides by N. So 30N is 720, and then divide both sides by 30, which is 24. So how many more workers does Haley use? 24 take away 18, which is 6 more workers. Question 29. The diagram shows a cube and a cuboid. The total surface area of the cube is equal to the total surface area of the cuboid. Janet says the volume of the cube equals the volume of the cuboid. Is Janet correct? So we're going to have to work out the surface area of the cuboid, and then we'll know the surface area of the cube, and we can use that to find the length of each side of the cube, because we know the length of each side of the cube is equal. So once we know that, we can work out the volume of each of them. So the first step is the surface area of the cuboid. So we need to add up the area of every surface. So the top is 8 times 18. Which is 144 centimeters squared. The bottom is the same as the top, so that's 144 centimeters squared as well. Then we've got the front, which is 6 times 8. So 6 times 8 is 48, so that's 48 centimeters squared. The back is the same as the front. And then we've got the sides. So 6 times 18 for the sides. So 6/18 is 108. And the other side is the same. So then the total surface area, that's all of these added together. So we've got two 144s, two 48s, and two 108s, which gives a total of 600. So the total is 600 centimeters squared. So we know the surface area of the cube is 600 centimeters squared, and the cube has got 6 equal surfaces. So the top, the bottom, the side, the front, the back, they're all equal. So 600 divided by 6 means each one is 100 centimeters squared. And if a surface, so a square, has got an area of 100, it must have lengths of 10. 10 times 10 is 100. So each length is 10 centimeters. So square root 100 is 10. So each length is 10 centimeters. So we know it's 10 by 10 by 10. So are the volumes equal? So for volume, it's going to be length times width times depth. So for the volume of cube is 10 times 10 times 10. So for volume of cube, it's 10 times 10 times 10, which is 1000 centimeters cubed. And for the cuboid, it's 6 times 8 times 18. So 6 times 8 times 18 is 864. 864 centimeters cubed. So are they equal? No, they're not equal. Question 30. Here are two column vectors. So A is 5, 2, which means it goes 5 right and 2 up. B is 3, negative 1, so 3 right and 1 down. On the grid, draw and label A minus 2B. So we could just work out what A minus 2B is first. So A is 5, 2, and we're taking away 2 lots of 3, negative 1. So let's do 2 times this first. So 5, 2, take away 2 3s are 6, 2 negative 1s are negative 2. So then taking away the top and taking away the bottom, 5 take away 6. Remember, we can use a calculator for this if we want to. 5 take away 6 is negative 1. And 2 take away negative 2. So 2 take away negative 2 means 2 plus 2, which is 4. So on the grid, we've got to draw minus 1, 4. So that's back 1. So let's start somewhere, anywhere. So we're going back 1 on the x-axis. So left 1 and then up 4. So that will leave us with this vector. And we'll make sure they know which way we're going. So it's left 1, up 4, and we'll label it as A minus 2B. And that is the last question.